Students, today we are going to learn about this Newton-Raphson method, which is a numerical method to find the roots of any function, means approximate root, and it is a subtopic of engineering mathematics. So directly coming to the topic without wasting time. See, first of all, I will talk that what is the principle behind this Newton-Raphson method, and it is a very good method. Out of other methods, this method is one of the best method to find the root of any function, approximate root, in less amount of time and less steps. Okay, so suppose that this is a function, this is xy axis, this is the graph of the function. Okay, now this purple line is a tangent at this point to this function. This is the tangent. Now what happens in case I start rolling this tangent on this curve, on this upper surface of the curve, then it will go like this. You can see now it has rolled and come over here. This is the point where it is a tangent. Now this is the, again it has changed its point and again like this. So we know this thing that root of the function lies where the value of function fx becomes 0, means y becomes 0. So what we see that in case this tangent starts rolling on this curve, then ultimately it is getting closer to the root. Okay, so this is the principle behind Newton's Raphson method to find the approximate roots. Okay, now how it is done, we will learn that. Okay, suppose that this is our function, this is the graph of the function. Okay, we will choose an arbitrary point on this curve, suppose x naught. Okay, this is the point where x is x naught, and over there we will develop a tangent. We will find out the tangent. We know this thing that tangent is a straight line, y equals to mx plus c. How m can be found? That is the slope of this line. That will be the differentiation of y with respect to x. Okay, now this purple line is the tangent. Okay, now what we see that this tangent is intersecting the x-axis at this point. So when this tangent intersect at this point at x-axis, over there y will be 0. So in case I put y equals to 0, means I want to find out this point where it intersects with x-axis, y becomes 0. In that case, x will be minus c by m. Put y equals to 0. Okay, so minus c by m will be the x. Okay, now this point minus c by m, in case I am putting in this function, is this curve must have some function, so fx. So in place of x, in case I am putting minus c by m, I will get the value of y for this function. Okay, now what I will do, that at this point minus c by m, I will find out one more tangent, that is shown by this green line. This is a tangent on this curve at point when x equals to minus c by m. Okay, now this green tangent is also intersecting with x-axis somewhere where y must be 0. So in case putting y equals to 0, I will get this green minus c by m. Okay, the point of intersection of this green tangent with x-axis. Okay, so minus c by m. Now in case I am putting this minus c by m for the second tangent on the equation of curve, I will get corresponding y on the equation of curve. Okay, so over there at that point when x equals to minus c by m for the second tangent, at that point in case I am drawing one more tangent, I have shown by the help of this red line, so I can find out the tangent at that point also. So that red tangent will also intersect with x-axis somewhere when y becomes 0. So over there I will get this red minus c by m. So this third tangent corresponding x when it intersects with x-axis minus c by m, you can see it is very closer to the root of this function. So in case I am putting this minus c by m in the function, so I will get the value of y closer to 0. So this is how we roll this tangent on the curve and finally reach root of the function. So what are the steps involved in Newton-Raphson method? So that we will take. See, suppose the function is y equals to fx. Okay, now take a point in RHS of the equation of curve. Suppose that value is x naught. So putting x naught, you will get y. Find the equation of line touching that point, means develop the tangent, that is y equals to mx plus c, which we can find out. Okay, now what we do, that in place of this y equals to mx plus c, in place of this y put 0. So what you will get, the point of intersection of this tangent to the x-axis. So in that case we will get x equals to minus c by m. Now put this minus c by m, this value, in fx, in equation of curve. Okay, if by putting this minus c by m we are getting y which is closer to root, very much closer, then it's okay. Otherwise repeat process 1, 2 and 3, just in place of x naught, now minus c by m you will put. So again minus c by m you will put, you will find the equation of tangent, then put y equals to 0 over here, you will get new minus c by m. that you will put in the equation of curve. In case the value is closer to the root, means y is closer to the 0, and then it's okay. Otherwise, again put that new minus c by m in this equation of curve. You can repeat till you are getting an answer accurate, very closer y to 0. Okay, now we will solve a question, a mathematical question by the help of Newton-Raphson method, and the function for which we have to apply is this y equals to e to the power x plus x, and we have to find the approx root. Okay, so let's start our iteration. So this is the function y equals to e to the power x plus x. So I am taking the initial value of x to be 2. Okay, now in case I am putting 2 in this function in place of x in RHS, I am getting y to be 9.389. This is the output of this function. Okay, now at this point where x is 2 and y is 9.389, I have to find out the equation of tangent. For that, I have to differentiate it to find the slope at that point. So differentiation of this function is e to the power x plus 1, and put this value x0 over there. So I will get the slope of tangent at point 2 of x. So the slope is coming out to be 8.389. Now the equation of tangent will be y equals to mx plus c. So in place of m, I am putting 8.389. Now how to find out the value of c? We know this thing, when x is 2, y is 9.389. So putting the value of x and y, ultimately I am getting the value of c to be minus 7.389. So y equals to 8.389 x minus 7.389. This is the equation of tangent. Now we have to find out that where this tangent intersects with x-axis, means y will be 0 over there. So when y will be 0, so x will be equals to minus c by m. So ultimately I am getting the point of intersection of this tangent with x-axis where x is 0.880. Okay, now put this 0.880 in this function. Okay, so I am getting this 3.290 y at minus c by n. So this is far away from the root. It is not 0. So root is not at this point, because root is at 0. So y must be 0. So it is not coming out to be 0. So this is not the point closer to root. Now what we have to do, take this as x0 as a new point and repeat all the processes. Okay, so 0.880 I am putting in place of x0. Now putting this value in this function, I am getting y to be 3.290, that we have already done. Okay, now find out the equation of tangent at this point, means where x is 0.880. Again differentiate and put the value of x to be 0.880. I am getting the slope to be 3.41. So y equals to 3.41 x plus c is the equation of tangent. Now how to find out c? When x is 0.880, y is 3.290. Put those values, c is coming out to be this. So this is the final equation of tangent at this point. Now we have to find the point of intersection of this tangent with x-axis, means where y becomes 0. So that is equals to minus c by m. So it is coming out to be minus 0.085. Okay, now put this value of minus 0.085 in this function, x to be minus 0.085. So y is coming out to be 0.833. It is also far away from 0. Y is not coming out to be 0 or closer to 0. However, compared to previous value, it is closer. Still, it is not very much closer to 0. So this is not the appropriate root of this function. So now again take this minus 0.085 and take it as x0. Now in case minus 0.085 I am putting in this function, in place of x I am getting y to be 0.883. Now at that point we have to find the equation of tangent. So slope at this point is 1.918. So y equals to 1.918 x plus c. How to find out c? Put the values of x and y in this equation. I will get c this. So this is the final equation of tangent at this point, minus 0.085. So y equals to 1.918 plus 0.996. Okay, now again the point of intersection of this tangent with x-axis, y will be 0. So minus c by m, that is coming out to be minus 0.59. So minus 0.59, in case I am putting in this function in place of x, I am getting y to be 0.076. Now we are very much closer to 0, so we can take this as a root of this function. This is the approximate root, means this point when x equals to minus 0.519 can be taken as approximate root of this function. So hope by this small lecture you would have understood the theory of Newton's Raphson method. Thank you.